Okay, good morning, good afternoon, and good evening to everyone around the world. Welcome to our monthly online sharing event. So as you see, this time we have our Tsung-Yen from Virginia also again. He's going to share the engineering culture in United States. So before the presentation start, there are a couple of announcements I would like to share. The first one is today's topic is not technical, at least not directly related to like civil engineering knowledge that as an engineer we used to. So in the presentation, if there's any like maybe have like terms or like other knowledge that you're not familiar with, after that it's fine. Feel free to ask any question in English or ask our speaker to elaborate certain PowerPoint for you. We'll happily to do so. And the second is, if you have any questions, you're welcome to type it in the chat box. After the presentation, I will read it to the speaker, or you can simply raise your hand to speak directly to Tsung-Yen to ask him questions. So okay, let's get started to our introduction. So as you may read in our in my promotional essay that the engineering culture in the United States, especially in the higher education system, has inherits so many different aspects from UK, from Germany, from France, and it's even dates back to 19th century when at the time of United States, the Civil War and President Lincoln time. And it's a very interesting topic. I think bringing Tsung-Yen today take us travel back in time to the origin of the engineering culture in the United States will help us understand better that as an engineer, what role we can be involved in the modern society of the United States. Well, since for the past 30-40 years, United States in terms of pursuing a degree and working overseas is a very popular place for all the at least Taiwanese. So I think this is the topic that worth to know more. Okay, so that's all my introduction, and let's hand the microphone to Tsung-Yen. You can start sharing your PowerPoint.
Yeah, thank you, Beth. Again, it is my pleasure to present the second half of the second part of my history in the higher education with you all in the OTEA. So again, I'm Tsung-Yen Tsou, and right now I'm the PhD student in Virginia Tech. So engineering culture is something that interests me, and also I have a chance to teach a little bit of engineering cultures for the undergrad students. So I think today I really appreciate OTEA and Beth and you guys provide me these good opportunities to share some of the topic that I used to share with my students in the classroom, but also we talk in also I have learned in my graduate course. Okay, so like the first quick questions, can everybody see my slides?
Yes, I can.
Perfect. Yeah, because now I can see your face. But so which means so if you have any quick questions or you just be confused by any kind of jargons, you can either unmute yourself and ask your questions, or Beth will help me to read your question from the chat box. Okay, so today I got many things to share with you. So but I understand we only have a limited amount of time, so I will try to make it clear, but sometimes I may power through some slides. But yes, my topic today is definitely about engineering cultures, a little bit of history of the tradition that American engineers or the engineer in the United States, they have been take from other traditions from the Europe. So my speech today will be divided in three parts. The first part is the six infrastructure of making engineering in the United States. It's more about the period before the civil wars or the antebellum eras, and later reforming for industry and recent reform movements is more a contemporary issue. The reforming for industry is after the civil wars, then the federal government and the Confederacy kind of like combine together, and they enter fast, speedy, industrialized progress. And the third part is more about the contemporary or maybe not contemporary right now, but like in the late 20th centuries, global or modern challenge for the engineers in the United States. Okay, so for the first part, the six infrastructure for making engineers, basically it's like the six traditions of United States engineers before the Civil Wars. So yes, there are six traditions. The first tradition is from Britain. So probably some of you may heard that in British, their engineers have bear a strong traditions in the apprenticeship or on the job or on the job you're learning by doing this kind of apprenticeship. So as a formal colonies of of the former colonies of British of Britain's United States also have this on-the-job apprenticeship traditions, especially for the early day civil engineers. Like for example, when they are building the area canals, you can tell from the historical data that they have this very direct mentor apprentice relationship between each of the engineers involved in the area canal project. The way they get their knowledge is more about practical knowledge. So probably usually they will just start from apprentice, and later they get more experience from doing their job, from on the side trainings, and then later they can get promoted to become a foreman, and then to become a site engineers, to become the residential, to become a residence engineer, and later chief engineers. So so you can see that's one tradition of the engineer of Americas before the Civil Wars. And also, not only area canal, but other infrastructure, other transportation infrastructure like roads, bridges. They have most of them have been built or established through these traditions. And usually they receive their funding from the private sources. And yes, there are some government sources, but the majority of the funding are from the private sources. And here's some photos about the civil engineers before the Civil Wars. That you can see they still use the same equipment to measure the altitudes and then to do observations. And also some photos, some old photos, but some more recent photos about the area canals. This is the first canals in North America. So becoming a civil engineer usually means you will spend a lot of time on your site doing the tasks. And yes, you can work as a consultant or you can work as a commissions. But usually it will be pretty lonely because you need to stay on your working site, and probably it will take you years or maybe more. It will take you months or more than years in theirs. And those civil engineers, they are not only have this apprenticeship traditions from the UK or from Britain, but also they have been inspired or aspire to become a professional gentlemen, follow the British traditions. So they will really want to use this opportunity as a civil engineers to promote their social status to become a gentleman. So that the traditions that those U.S. engineers, early days U.S. engineers, adapt from the UK. And then the second infrastructure is the national military academies, and the most significant example is the West Point, established in 1802. And yes, it's ordered by President Thomas Jefferson, and their first superintendent or their first president has been appointed in 1870s. And the Seventh Steyr, he have a very strong French military school backgrounds, and he used to study in the top one military also engineering college called École Polytechnique. So he used to study there for 2 years. And since the superintendent have been strongly influenced by the French traditions, so they also so he also employed instructor from France like the Claudius Cozier. Some you may hear. Some of you may heard this guy. And for their curriculums is very math heavy because it's very math heavy. So as a student, you also need to do military trainings, but you will spend a half day focused on math, and you will spend another half day focused on French, because you need to know French to read those to read those textbooks what's written in French. So since you already need to learn French and a lot of math, so there are complaints from the faculty about they don't have enough time to have more to learn more advanced math. And West Point is a military school, and also it's a tradition from France, because in France their engineers begin from building fortress or digging out trench. So in the beginnings, the French engineer also called engineer for fortification and engineer for trenches. So you can tell they are military engineers. So this kind of tradition have been bared by the Ecole Polytechniques. So they also really focus on those military trainings. And another part of their engineering training is math, because in their traditions, they will really want to numericalize or mathematicize any kind of phenomenon. They have this eagerness to use math to explain all kinds of engineering problems. And also, West Point have followed the same models in France. Most of the graduates from the West Point will serve in the federal government, will serve in the military, and later serve for the federal government. And also they have been produced maybe a half of a civil engineer in the United States by the 1850s. So here is the first superintendent, the president's civil style. And you can see that the textbook that he used in France, and also the textbook he used in the early days in West Point, are all in French. All have been written in French. Another photos of West Point in 1820s. So this tradition are more focused on the rational leaders in the government. So basically, it's provide a way to train bureaucrats to work for the federal government, and they were very focused on apply mathematics to all the constructions, and to use scientific knowledge to legitimize leadership in the government. So we not only have the traditions from British, but also we have tradition from France, from the Britain, but also have tradition from the France. From Britain is more focused on the practical knowledge, and from France will be more focused on how can you mathematicize your problems and to gain knowledge to solve your problems through math. And then there's kind of like other traditions also have been influenced by the Britons. Is that during that time there are also this individual college. The classical college have been established in the colonial times, begin to teach some kind of and begin to provide diplomats of engineering, just like either they will provide you individual courses, or they will give you a bachelor degrees, or some of them even give them a non-traditional Bachelor of Science degrees. But this kind of training are not aimed for the engineer, just because people believe if you want to build a holistic gentleman and must have some masculinities in your characters, then learning science and maybe learning a little bit of engineering, but oftentimes still liberal art, can help those young students build their characters and help them to become gentlemen. And another infrastructure is the independent technical schools. This type of technical schools are not funded by the federal government. They receive their funds from philanthropies. The most well-known case is the Rensselaer schools. Later have been renamed as the Rensselaer Polytechnic Institutes. And in the beginnings, they are also focused on teaching science, and later they gradually changed to engineering programs. And they have also been influenced by the French tradition, that they believe we not only need military personnel who have received engineering trainings, who serve for the government. We also need some civilians to receive to receive engineering degree to serve for the societies. So not only serve for the government, but also for the larger societies. So that's kind of like their goal, that they want to use their technical schools to promote to help civilians to learn to help civilians to learn engineering knowledge, and then later serve for the societies. And another, we probably also, because United States you have a federal government, but also have state government and have a local government. So state governments also want to have their own armed forces. So they just emulate the federal government. So they just emulate the model of West Point and run their own state military academies. So basically, they are just like they are just like the replicas of West Points. Like they also hire faculties who used to study in France, and they used French textbooks. And but those kind of students, after they finish their degrees, they will serve for the state, serve in the state militias. And also for their curricula, for the course they take, are still very math focused. So there are still some of this kind of military technical school in Virginia, or also in South Carolina, like the Virginia Military Institute or the Military College of South California. Oh, sorry, the Military College of South Carolina. Sorry about that. And the last infrastructures, because the previous one, yes, they will probably focus more on the civil engineers and also like some kind of more basic engineering knowledge. But then the sixth infrastructures is more focused on the mechanical engineers. So yes, so for the mechanical engineers, it's just like civil engineers, the civil engineer who help build the marine canals. For the mechanical engineers, they just work in the machine shop, or they just work in the factories. So the origin of the machine shop have been growing during 1810s to 1814s, and at that time for machine shop, there's no very clear divisions between the owner and the mechanics. Basically, just like owners and work with his colleague. So both of them are skilled craftsmen. But later, when the organization or when the company become large, begin to grow, then you will have more people. So then you need more people. So then you need some basic managerial class. So at this time you will have the unskilled laborers, and then you will have skilled labor, later called foremen. And if you spend enough time as a foreman, then you might get a promotion to become superintendents, and so on and so on. So this kind of mechanical engineers somehow still receive some tradition from the Britons, that they believe those kind of mechanical engineers, they not only have knowledge, they not only can build things, can build machine, but they can also be a gentleman leaders in the industries. And this is kind of important because this is kind of important because later they have been getting, because later when they began to grow larger, and then then they began to compete with the other mechanical or machine shop in Britain and in France. So this might be the first well-known machine shop in Philadelphia, the William Sellers. So after the Civil Wars, then the federal government and the Confederacy, they have been merged together, and for the North federal governments, yes, they have been industrialized, but for the Southern Confederacies, most of them have been stay with this agrarian economic model for a long time. So basically, they are not industrialized. They are just farm, and most of people work in ranch or work in farm. So after the Civil Wars, the federal government really want to industrialize the southern part. So one part of industrialize the southern part is, yes, you build more school to train more students to train more students to work as engineers, and also the company began to grow because now there's no war, so then people can more focus on produce, and the market become, and then the market are back, and also the trading market is back to work. So during these times when the industries and the civil society is both booming, then the people's salary also become to grow. Then this kind of high demands yield some kind of high productions. So one character quite significant here is the low cost productions for the mass consumptions. So just because you just have so many demands, and so you will try to produce more for mass productions, but also not really care about the qualities. It's like, so just like low qualities but mass productions, meanwhile low cost. So this somehow changed the traditions of the apprenticeship and also changed the tradition of the industrial gentlemen. And I think, and also the single sewing machines is kind of like an example during this time. The single sewing machine is very durable, because it's very durable and it's easy to operate, but also it's easy to produce. And another significant point for the low cost and mass use or low cost mass productions will be after the Civil Wars. Not only now after the Civil Wars, people begin to move to the West, which means they will move to the Midwest of the United States. So they just open they just open more land, and also try to also colonizing some of the lands, and to extract more resources. And also after the Civil War, there's rapid spread of the railroads, and also there's a shift in immigration to unskilled laborers. So just like there are immigrants from China to help building the railroad in the United States. So they are just like, when the business is growing, when the corporation is growing, they will also figure out a way to reduce labor costs. So the first large corporations, or the first large corporate bureaucracy in the United States, is the railroad companies. By using several business techniques, by using several business strategies, they try to merge their opponents, and they try to like divide and conquer, and in the end, like somehow buying the whole railroad systems. So in other words, just like the railroad system in the United States after the Civil Wars had been controlled by maybe by only several monopolized companies, until there's antitrust act, and then those companies begin to die down. So this kind of huge corporations also facilitate or also give birth to large unions, because you have a large shop floors, you will have a lot of workers, and those workers and the shop floor provide easier speak the word a little bit, just like they begin to conflict with the unions, and then also the government begin to interfere into some of the corporate business. And also, it's also during this time, the corporation, they turn to science, they turn to research and development to try to control knowledge and try to invent more new technology, especially in the electrical and chemical industries. And also during this time, the organized laboratories, the huge laboratory like the Bell Lab has been built in these times. And also because there are very fierce competition between different corporations, so the systematic patents procedures has also been established during 1880s to 1920s. And then meanwhile, the union just grow bigger and bigger to protect the workers. while the government they begin to regulate and they begin to try to break those monopolies. Also, there are also it is the time that the engineers or the engineering become to grow more become to become to diversified. So in the beginnings, there are just two mainstreams of engineering or engineers before the civil wars, there are civil engineers, and also they include army engineers, engineer for fortification, and engineer for digging trenches. And later for the civil engineers in the 1850s and to 19s, they are mining engineers. So just like civil engineers, and then they have been combined with mining, and there's mining engineers. And just like in the early 2000s, they are environmental engineers. So civil engineers, they are just like civil engineers all the way. They are kind of like this huge, they're kind of like a huge tree, but don't have too many branches. However, for the mechanical engineer, just like the engineer begin as a apprentice in the machine shop, and later these old disciplines of mechanical engineer begin to combine with new type of science, new type of scientific knowledge, and become new disciplines. So in the late 18th centuries, there are electrical engineers, basically are just mechanical engineers and combined with the electromagnetism. And there are chemical engineering in the early 19th. So there are mechanical engineers combined with chemistries. Also industrial engineers, they are just mechanical engineer combined with management. And then in the 1950s, after the World War II, the aerodynamics begin to grow. So there are also aerospace engineers have been emerged during this time. And later in 1970s, here's the computer engineering. So that's the like the basic landscape after the Civil War. That's after the Civil Wars, there's no more domestic warfare happening in the United States. So the business have been growing into corporations, and then also there's engineers and engineering also growing with the corporations to have more branches. And then in the third part, we will just roll back to the academia, to the school, to the college, to see what's the recent reforms for the engineering educations after 1970s. So before 1980s, everything was good, and you have a steady you have a very steady recruitment, and you have somehow steady growth for the new engineering students, and also for new engineers. But then later something happens, and people begin to recognize there's some problems or troubles happening. The first problem is people figure out that their recruitment rate have been declined, especially for the 18 to 22 years old white males. They used to be the majorities in the engineering degrees. And also those presidents from the university, they also found that the retention rate has been pretty low. Like the total retention rate for engineering degree is 70%. And also the retention rate for the white female students is 40s. For African American is 20s. And for the Hispanic American Indians and also maybe aliens, they are just less than 20s. So they really concern and care about these problems. So kind of like during this time, or before this time, the well-known STEM pipeline, or before this just engineering pipeline, has been this theory has been brought up. They just assume that this whole process just like a pipeline. So you will have input, but you'll have output, and for increasing the retention rate, or for having more engineers in the futures, we need to find all the leakage around the pipelines to have more yield in the end. So just like from the STEM pipeline, you also have women in the engineering pipelines. So basically, they just follow this model, and they try to find all the leakage. So like from these figures, from this picture, you can find they are just they find several reasons why women cannot stay, why women have a lower retention rate in our engineering degrees, just like chilly classroom climates, or maybe they don't have enough capability about this, or feeling of isolations, poor academic preparations, or uniform choices, something like that. So after they build this model of engineering pipeline or STEM pipeline, and they think they find all the leakage, those reasons like chilly class atmosphere, not good in math, then they begin to build a policy, or they begin to build plans for enhance the recruitment, but also enhance the retention rate. So they provide several proposals, just like strengthen the K-12 math and science preparations, or build relation with 2 years college, and establish transfer programs, and also better public relation materials, and encourage the faculties in the engineering department to spend more time on teachings, something like that. But also there are also other kind of awareness begin to rising during this time. Is that people begin to aware about the gender and ethnic isolations, especially in the engineering classrooms. So there are also people propose about enhance the students' involvement in engineering classroom, just like more energy devoted to studies, or more time spent on campus, and also have more student organizations, and faculty need to be more accessible and also open to the students, so on and so on. So that's kind of like the first movement about, because they want to have more engineers and want to make more engineers. And then the second reforms happened in the 1993 is about make flexible engineers. So basically, this make flexible engineer is that the world is too complex. But the previous trainings in the previous trainings in the engineering curricula are more focused on teaching you how to do math, how to solve equations, how to solve problems, and also teach you physics, chemistry, all this kind of stuff. But they are all focused on problem solving. So engineers are more focused on solving a problems in a given conditions. Since the world is so complex, so we cannot only use engineering knowledge to solve all the problems. We might need other things. So this is like a concern happened in the 1990s, that people begin to ask for a more flexible engineers. In other words, just like broadened the scope of problem solving. So how to broaden the scope of problem solving and make them more flexible engineers? They also propose some plans. One of them is to develop an integrated approach. So it's now, if you kind of like enter any kind of engineering degrees, if you take a look on their learning goal, or on their curricular design, or on the purpose behind their curricula, you might find those integrated requirements for engineering students. So it will require not only how to apply knowledge, not only how to design systems, not only work with multidisciplinary teams. It will also ask engineering students to understand other value or other knowledge outside of engineering. So they will be understanding the professional and ethical responsibilities. In today's the engineering ethics, or also ability to communicate effectively and understand the impact of engineering solutions in a global and social context. So it's kind of like understand the consequence of your engineering problem solving. And there also recognition of the need for and ability to engage in lifelong learnings, and also their knowledge of contemporary issues, just like global warming, climate change, or nuclear disaster or flood. So this second reform is more focused about how can we broaden the scope of engineering. Engineers are not only focused on solving problems, solving an engineering problem, but also engineering problem can have impact to the social, to our society, to our futures, to our environment. So engineers need to be more flexible, need to know more stuff when they are solving a problem, or need to have ability to communicate with different group of peoples. That's the reform happens in the 1993 in the United States. The last one is about how can the US engineers face a global challenge. So yes, like Thomas Freeman's well-known book is called The World is Flat. So also engineers, the US engineer began to face a challenge from other country. He used to be engineer from Japan and later is engineer from China, but also they are always facing a challenge from the Europe. So for be a competent engineers in the global markets, or to work as a global engineers rather than only engineers. Today is more and more engineering degree or engineering programs will require the student to have a second language proficiencies. They will need to have a comparative global knowledge. So they probably need to learn a little bit about the global politics or the international relationship to understand the social, political, economy process and systems. And they need to have an intercultural assimilations, which means they need to understand there are more than one cultures. And also other engineers might have other engineering culture or might have other cultures. So they might define their question differently, or they might use a different way to solve their problems. So that's all about my presentation today. And probably because I just powered through several stuff in my slides. So if you have any questions or if you're just curious about anything, I'm happy to answer all the questions.
Okay, thank you very much, Yan. That's definitely a very in-depth, like a review or like a very deep dive in the past and current, like not issues but social context. So I will have something to share because in the last few slides you mentioned a modern engineer facing the not only the local industry but the worldwide industry, because US they expect like engineers to different parts of the world to do business, to do engineering work. So you mentioned nowadays as an engineer, no matter where your background is, like I'm a civil, you're chemical, doesn't matter. Aside from your like a basic technical knowledge, you better have possess a more diverse knowledge to become more flexible. Like you better understand the politics between the two countries and the policies related to your like infrastructure, whatever, like maybe the treaties between US and China. How does that affect like Tesla factory in Shanghai? Me, actually, I think nowadays as an engineer, we really have the opportunity to become a modern gentleman, because you know what? Looking back, like what does a gentleman do? Well, they're aside from their military military service or military responsibility to their people, they heavily involved in diplomacy, right? They speak several languages. They're easygoing. They're knowledgeable about many stuff, not just technical part. So that's my take. So do you find this becoming a trend like nowadays, because the technical knowledge is easier to get? You buy a course online and you can easily like download to your brain, but the other values, like getting more aware of the different cultures, it's harder. And do you think that's a modern engineer's challenge? What's your take?
Oh, yeah, I think your question is very inspiring, especially you bring back, especially that modern gentleman. I think that's a really good takeaway from my speech, and appreciate it. I think for the ancient time gentlemen in Britain's, they because gentleman is like something not belong to the noble peoples, not belong to the aristocracies. but also they are above the peasants. So gentlemen is something that the middle class people who own a shop, or people who have some specific skill, they want to enter this social class called gentlemen. So yes, in Britain's in the 18th century or in the 19th centuries, a lot of apprentices, after they earn enough skill, they become they have their own shop, and they become a skilled they become British engineers. They will also want to become a gentleman, not only because they want to enter a higher social class, but also they want to uh, but also they want to become leaders in their communities. So for becoming a gentleman, you definitely need other things. You definitely need more knowledge, not only your technical knowledge, but also you need to have other on technicals, which maybe liberal art or some things. And for this, I would say the military engineers, the military engineering in France also have this kind of same patterns, that the military engineers in France, they need to learn a lot of math, but they also need to learn how to serve for the government, especially if you are an engineer in the Eco Polytechnic. So you serve in the military, but you're also engineers, and you need to also know how to work with the bureaucracies. So I would say engineers is so probably like 100 years ago, engineers are already work with different group of peoples, and also receive and learn different skills to try to make sure they can not only finish their project, but also maintain their career, and also there are kind of like social value, or there are kind of social value and culture values that have been bared, or they want to promote when they are serve as engineers. For today's, I'll say this kind of global challenge or globalizations, they are still happens because I teach in the I used to teach class in Virginia Tech, and it is an engineering school. I teach a lot of my students. They are either scientists or engineers. So they all aware that even no matter what kind of major they have, either they want to work as computer engineers, or they want to work as civil or construction managers. They all need to communicate with people have different social, culture, or national backgrounds. So just like a lot of students, it is also requirements, but a lot of my students, they also learn second language, or maybe they learn third language. Many of them have been very fluent in Spanish, because they said maybe in the future they need to use Spanish to communicate with their colleague, or communicate with their business partners. So I think this kind of recent reforms, the make more flexible engineer reform, or make more global engineer reform, definitely improve, or definitely change the career of engineer, or change the abilities of engineers in the United States. But still, there are complaints, or still there are critique about engineers are so focused on solving their own problems, but they cannot only just simplify a problem and solve it through engineering majors. You need to have other tools to help you solve the problems. So I think it's still a progress. But what I want to say is that the new generation of engineers, they're already aware the trend, or the world is changing, so they need to change to catch up with this trend.
Thank you, Yan.
Yep.
Very appreciate for the detailed answer. Thank you for your insightful presentation on this topic. Your expertise has provided valuable insights, undoubtedly broadening my horizon. I'm Ted. I have a couple of basic questions. The first one is, how did you navigate challenges such as securing funding and reaching out to advisors during your first academic year at Virginia Tech? And the second one is, what's the most valuable aspect for you while pursuing your degrees?
Yes. thank you for asking those questions. And I think they are really good questions for me to reflect on myself. For your first questions, I would say because our department, because I I received a scholarship before I received an offer for the scholarship before I accepted before I entered Virginia Tech. So I am under a 4-year scholarship contract right now. So scholarship will pay for my tuitions. I still need to pay a little bit of my other fees, but because it's covering my tuitions. So right now I don't need to worry too much about my tuitions. But for doing research, I definitely need to write proposal and to try to write a grant proposal or write a fellowship proposal to get to get more funding to help me to do my research. So I would say the most challenging part is that how to, especially for people in the academias, is how you translate the language or the jargon that you use for for the people who don't really know what you are doing. It's basically just like how you do some public communications to translate your language to other people's language and make them interested in your own project. Then they will need to fund you. So I think that's a skill or technique most challenging to me right now, especially I'm a non-native speaker. So writing a grant proposal or also writing a fellowship proposal is definitely challenging to me right now. Uh, but I'm very fortunate that in my department, my advisors and other faculties, also my colleague, my cohort, my classmates, they are quite supportive and they are all very generous and willing to share their resources and their opinions and information with me. Kind of like we just keep sharing information and also resources to each others. So I don't really have difficulties to find my advisor. And also for other people who want to find advisors in my department, as far as I know, it's quite easy for you to switch from advisor A to advisor B, and it won't cause any hard feelings. But I also heard other very terrible stories from other departments. But there will be another issue. But depends on which university you are in. But in our universities, if you are kind of like if you have a very deep conflict with your advisors, there will be there are systems called university grievance. I can also post a link on the chat box. So the university grievance is kind of like it's like a way to help you reconcile or help you figure out a way to gain your rights, also protect you from any kind of abusive or aggressive behaviors. Alongside this grievance, there are also some universities might have ombudsmen, which is confidential legal consultants in the universities. So you can just talk to your legal consultants, to your ombudspersons, or to your ombudsman. Then they can help you, or at least they can direct you to some resources, and later help you to either find another advisor or just to find or to reconcile your conflict with their advisors. Yeah, but for basic reaching out to the advisors, usually just write emails, and if they didn't answer your email back, then you either do a follow-up or you change to another person's. And for the valuable aspect, because I'm kind of like in the interdisciplinary field, although most of my research interest is focused on public policy, I often thinking that sometimes we we need to implement some of the ideas either into engineering project or implement an idea into some doable practical project or implement an idea into a policies. So then we can either just make our idea work or make our idea become some kind of infrastructures to enable other idea that we value can work. So that's kind of like so I think the valuable aspect I learned from my degree is that how to make things happen. So how to implement idea into practical project or policy is something I'm very valuable, and I'm still learning, but I also think the valuable part of my degree.
To the first one, navigate challenges. Well, as an immigrant and as someone grew up in Taiwan and come to US after I graduated from college, and being in US for many years, I found a lot of the challenges coming from you don't understand how the society works and you can find no connection with them. And that's the most challenging part, and it's invincible because it's not a formula written on the paper, and you can, or on the screen, you can go solve it right away. So and this kind of pressure is 24/7. You face it on daily basis. But if you are always hanging out with your own comfort zone, your own Chinese bubble, Taiwanese bubble, you won't have any challenges at all. Yeah. But if you want to stand with your own feet in another country, doesn't matter if it's in US, but maybe UK, maybe Australia, I would say spend some time like getting to know their classic literature or their newspaper for the current issue. I know it's very far away from the technical like science book or the engineering book that we used to read. But let me share a real story from me and Yan, because we are brothers and sisters. So when we were young, well, especially me, I remember when I was in high school, after I'm done with my homework, I go read other literature, like books. Well, I'm not reading anything too weird, just like Gone with the Wind, some American literature, some English literature, some French literature. Yeah, and my dad saw that. He will nag at me. See, he said, well, you finished reading the high school math. Why don't you move on to the university calculus? So he was nagging me like that. And I did not argue with him at that moment. But also I didn't follow his advice because I think that's too boring. I don't want to read it. And even though like reading only textbook is oh my God, that will kill me. So I just didn't follow his opinion and just do what I want to do. So I read a ton of different literature from different countries, different time in history. And 10 years later, when I come to US, I find that what helped me blend into the society, what makes me understand what Americans think, are the garbages I read in my high school time. Not the science book, not the university textbook that helped me blend in this culture. So it's not easy, I understand, but worth a try. Okay, we are over the 8 o'clock, 12 o'clock already. So let's we can stop recording and moving into Chinese session. Thank you, everyone.
Thank you, everyone. Thank you for being with me.